So good day everyone. Today I'm going to perform our performance task 9, which is write number 1, write a description for 8-bit shift register. So it is composed of shift register that has serial inputs seen and output is out. Then it also has 8 parallel inputs. The data input or DN 7 down to 0. So it is synchronously loaded from this input. When its load input is assertive, well, active high, so ma-on siya. So it also has synchronous active low, reset input, and reset. When it shift R input asserted, so if ma-1 siya, it contains one position to the right at the next position positive edge at its clock input. So I have truth table here. So this is my truth table. So if our clock is 0, then our N reset load shift R and SN is, it will become don't care. So if our clock is 0, then don't care. So if our clock is 1, then our N reset is, then if our N reset is 1, then the rest of this it will become neglected, so it will become don't care. So and then if our clock is 1, then our N reset is 0. Then if our load is 1, then same, shift R and SN is don't care. So if our clock is 1, then N reset is 0, then load is 0, and shift R is 0, RSN is neglected or don't care. Then and this, if our clock is 1 and N reset is 0, load is 0, and shift R is 1, then this the shifting occurs. So the serial input will become 1. So the serial output of 7, so ma-moves ang serial output sa 7 ma-move sa 6, then ang serial output sa 6 ma-move sa 5, and so on. Then if our clock is 1, then N reset is 0, load is 0, shift R is 1, then our SN is 0, then 0 is moved to since SN7. The value of 7 is moved to 6. So move siya sa next positive edge of at its clock input. So that's it. So let's try if my codes work. So I have module bit, so it is a bit shift register, so I named it bit 8. So just name it bit 8. So clock, N reset, SN, load, and data input, shifter, and this out. So I have input of clock, N reset, set, shift R, and load, and I have buses of data input and buses of data is output out. Then this if our N reset, so we check niya ang value sa N reset. If it is equals to 1 or 0, then i-perform niya ng the same sa truth table. Then if load is 1, then data input will is equals less than or equal to data input. Else if our shift R is is 1 and R is equals to Sn. Then so this part mo di itong shifting mga core, ang value sa 7 move sa 6, then ang 6 move sa 5 and so on, then S out, else if S out then is less than or equal to S out. So bit 8 stimulus generator and this bench. Then let's try to run this. And it's called VVP VVP. So this is the result. That's all and thank you.